All right, this is a review for your quiz on Chapter 6, which will be on Friday. Okay, so here's an example. Suppose that a group of consumers, the proportion who eats pretzels is 75%, and the proportion who drinks Coke is 65%. Further, suppose that the proportion who eats pretzels and drinks Coke is 55%. So we're going to define the following as A, the consumer eating pretzels, and B, the consumer drinks Coke. So number one, you're going to sketch a complete Venn diagram that represents this. And number two, what's the proportion of Coke drinkers who also eat pretzels? And then three, determine mathematically whether these two events are independent. All right. So sorry, I didn't have my computer at home or my whiteboard at home, so I had to do this by hand on my computer. So those circles are A and B. Okay, so right here, do this part in the middle, the part where they intersect, the 55% right here. Okay, and I think they said pretzels is 75%, so that adds up to 75% right here, and the Coke is 65%, so this adds up to 65%. And all of these add up to 85% right here, so this is the leftover, the 15%, okay? Piece of cake, piece of pretzel. Okay, what proportion of Coke drinkers also eats pretzels can be reworded as what proportion eats pretzels given the fact that they drink Coke. Okay, so that's going to give us this formula here, which is out of your notes. And so that you're going to convert that to the probability of A and B divided by the probability of B. All right, so the tricky part is this part right here. So just be able to reword that. And then it's just punching in the numbers and you get 0.846. Okay, and then they're independent, you guys. If they're independent, when I introduce that to you, then the probability of A and B would equal the probability of A times the probability of B. So we know the probability of A is 0.55. They gave us that, and so probability of A times B is that, and so they're not equal to each other, so they're not independent. Alrighty, easy enough. Okay, so here's another one. A bag contains 5 marbles, 1 red, 2 white, 2 blue. Player A draws 1 marble without replacement, and then player B draws 1. What's the probability that the 2 marbles of the same color will be drawn, and then what's the probability that at least one of the blue marbles will be picked? All right, there's a couple ways to do that. I'll show you one way, you guys, and I have the answers right here. So the same color, you can get a white, and then a blue and a blue. And it says without replacement. So there's 2 white out of 5 marbles, so we didn't replace it, so there's only 1 white left out of 4 marbles, okay? Or means addition, you guys, so you can get a white white or blue blue, and or is addition, okay? And then there's 2 blues out of 5, and then so you get 1/10 plus 1/10, you get 1/5 or 0.2. Your book loves the decimals there, so it's 0.2. Okay, what's the probability that at least one blue marble will be picked? Okay, now a red and a blue is different from a blue and a red because different people are picking them, you guys. So you can get a red blue or blue red. You can get a white blue or blue white, and you can get a blue blue. Okay, at least one blue marble. Okay, so here we go. All those probabilities. Or means addition, and you add them all up, and you get. Whoops, there should be a fraction bar right there. 7/10 right there. Okay, and then so it's 0.7. Whoops, 0.7. Okay. Let's see, my mouse gets a little carried away. Suppose there are 10 multiple choice questions on a quiz. Each question has 3 choices, A, B, and C, for the answer. Unfortunately, you went to see the movies the night before and were unprepared for the quiz. Unbelievable. I never do that. You decide to guess the correct answer by randomly choosing one of the 3 choices. So describe a simulation to estimate the probability of answering, there's a G hidden back there, at least 4 of the 10 questions correctly. So how would you use a random digits to simulate the person guessing correctly? Okay, that's easy enough. Use the random digits starting at line digit table, table B, at line 103 to carry out the 3 repetitions. To simulate 3 quizzes, so keeping track of your results. So we're going to simulate taking 3 quizzes on this. And then according to your results, what's the probability that you answered at least 4 of the 10 correctly? Okay, so let's take care of this. Whoops, a little too far right there. Okay, so how would you use the random digits to simulate a person guessing correctly? Okay, since there's 3 choices, you guys, and I let 1, 2, and 3 be the correct answers, and then 4 through 9 be the wrong answers right there. And we ignore 0 right there, okay? And let's see, so number 2, Use a random digit table starting at line 103 to carry out the repetitions and simulate taking the quiz 3 times. Okay, so here we go. Here's line 103 right here. And then out of line 103, remember the digits 1, 2, and 3 are correct. So there's one correct answer right there, that number 1 right there. Okay, none of the other ones are correct. Okay, in this one, there's 2 correct answers. These 2 guys right here. These are my 2 correct answers right here. And then over here, there's 5 correct answers. That one, 1, 2, 3, 4, 5. Okay? So it says out of these 3 tests, we got 4 or more correct ones. So the answer is 1/3. All right?